So there's been a lot of interest in this solar freaking roadways idea. One of the biggest things brought into question by people is the road surface, and the right to question it. Glass is a terrible surface for driving cars on, particularly when you want to try and keep the glass relatively translucent to ensure the panels underneath are receiving plenty of light. Now, I'm not even going to go into the problem of car braking and friction coefficients in this video, which they claim on the website they have good results for, which may be possible if you corrugate the glass like what they have done. But have you ever driven on a corrugated road? Ever experienced your entire body vibrating while it sounds like your car is shaking itself to bits? Perhaps not the most comfortable ride. But anyway, as I said, I'm not going to talk about this. I'm just going to use my knowledge as an engineering student to design my own panel of glass for this application. Try and get a handle on the cost of such a material, because they've been pretty vague on the cost of this project. If you look at their website, they say their panels will support up to 250,000 pounds, which is about 115 metric tons. I mean, wow, that sounds great. But when you actually look at how the tyres on a truck are arranged, the maximum loading on the largest triaxle bogie consisting of 12 tyres, allowed under Australian law, which would be similar to the US, is 20 metric tons. Which means that it doesn't matter how big the haul is, more tyres will just be added to ensure this maximum load on a single tyre is not exceeded. I mean, it's like saying we can support a 50th of 250,000 pounds. It makes no sense. Okay, so how much typical load would be on one dual tyre? Well, we could take the maximum allowable load on one bogie and work out how much load would be on one dual tyre that is sitting on a single panel. So 20 divided by 6 is 3.33 tonnes, which is about 33 kilonewtons. But what if something fell on the panels? Surely we don't want glass flying everywhere when, say, a truck drives over a piece of rubble. Let's say a truck drives over a 20 centimetre object and the tyre slams back down on the panel. What force would that be? So, to calculate the stopping force, we need to get a number for S, which is the stopping distance, which in this case would be the deflection of the tyre when it falls on the ground. We can assume this to be about 5 centimetres, which is worst case scenario. So, this works out to be about 130 kilonewtons. Okay, so we have some design requirements, but we are forgetting something. The very abrasive effect of traffic driving over the road. Abraded glass is very common. It is also known as frosted glass. Now, I don't know of anybody ever using frosted glass on the top of a solar panel, but let's just agree that will drastically reduce the efficiency. We also want a high refractive index, which means that any light passing through the glass will be directed towards the solar panels at closer to right angles to the normal of the surface. Now, glass is a very complicated material to understand in an engineering sense, much harder to understand than steel. If you know anything about ceramics and glasses, you know that their failure load is a function of a probability, that is, the probability of micro cracks that will propagate to cause the whole structure to fail. Often trying to draw conclusions from a standard test to predict how a similar product would perform is somewhat of a best guess, which is why glass products are made and then tested in their manufactured form. Now, I don't have enough money to, start manufacturing my own panels and testing them, but I can still draw some conclusions from this data and try and get a product that would probably perform quite well. Tempered glass is a very hard variant of ordinary glass, which is subjected to heat treatment. It is used on car windshields and helicopter windows. Tempered glass has a benefit of breaking into very small shards, because if you're driving over glass, we don't want massive shards everywhere. Having said that, I personally wouldn't want to drive over glass, period. You often see parking bays free at the shops because there's a pile of the remains of someone's car window there. Now, we can help make this safer by laminating glass. This layer will help keep the glass stuck together after it is broken and will greatly reduce the risk of tyre punctures. This laminate will ensure that even if the top pane is broken, the pane underneath will still have some load-bearing capacity, which will help protect the delicate electrical components underneath. Okay, so we have our chosen glass, which has a yield point of between 120 to 250 megapascals. Now you might say, wow, that's fantastic. This glass is nearly as strong as steel. You'll be almost right, but it's irrelevant when dealing with beam loading of glass or a ceramic because, as I said, glasses have micro cracks, and you have to look at the fracture strength to determine what force we need to develop these large cracks in the glass. By assuming the shape of the panel is square, that makes things a little bit less complex. So let's say the panels are 30 centimeters by 30 centimeters, and let's make them outrageously thick, let's say 50 millimeters, or about 2 inches. So one thing with laminated glass is for short-term loading, both panes act like one chunk of glass. But for long-term loading, you must only consider one single pane. So let's see, we have an impact capacity of 160 kilonewtons and a general loading capacity of 40 kilonewtons before fracture, which fits our design criteria with a small safety factor. The problem is, 50mm thick tempered laminated glass is extremely expensive. That's what they use for bulletproof glass to prevent AK-47 rifle fire. Doing some research, it was hard to find a price, because most bulletproof glass is about 10 to 15 millimeters thick, not 50. But after some digging around, I found a price of about $100 US per square meter. Now, imagine a hypothetical road that is 6.5 meters wide and 1 kilometers long, and you want to line that road with this bulletproof glass. It would cost $650,000 US just for the materials for 1 kilometer before any money is even spent on labour, and they want to cover all the roads in the US with this stuff. Are they insane? In comparison, asphalt costs about $30 US per square meter, including all labour, equipment hire, materials, everything. That's less than a third of the cost of just buying the glass surface. Now, tempered glass has an abrasion index of 0.8%, which means that after 2 minutes of being sandblasted in the testing machine, it only loses 0.8% of its mass, which means high percentages indicate a material that performs worse. Road aggregate is 0.8% or more, so we can say that tempered glass is as good at abrasion resistance as a road surface. But the only problem is that glass need only be abraded about 1mm in thickness to become frosted, whereas a road might typically need resurfacing after 5mm of abrasion. Typically, a road needs resurfacing every 10 to 20 years, but we have the same abrasion resistance as glass, but we only want to allow it to be abraded at about 1mm. Any more and the glass will become severely frosted and will eventually start weakening due to fatigue. So that means in comparison to asphalt, the surface would need replacing every 2 to 4 years. So if we assume that, say, 20% of the panels on our hypothetical 1 kilometer road need replacing every 2 to 4 years, over a 10-year period this would cost between $325,000 and $650,000 US just for the glass. That compared to just simply resurfacing the road with an extra 5mm of asphalt is astronomically more expensive. Now, there's heaps of other things that are ridiculously expensive about this idea, like the service tunnels running alongside the road that would cost an absolute fortune for a start. This type of amateur engineering is like expecting a homeless person to afford to maintain a Lamborghini. If these solar panels were constructed, which they won't be despite all the money these morons have poured into it, we would end up driving on broken glass and electronic components instead of asphalt, because it is astronomically expensive to try and maintain. Instead, this money has just lined the pockets of these scammers.